Hi everyone. Let's talk about initial value problems involving indefinite integrals. In the first exercise, we're given a function 3x squared plus sine of x, and we must find the antiderivative of f whose value at 0 is 4. Let's start by finding the most general antiderivative of f of x. The most general antiderivative of f of x is 3. Then I apply the power rule and I get x to the third power over 3. That's the power rule for integration. Then I find antiderivative of sine of x, and antiderivative of sine is negative cosine of x. Finally, I add c at the end. Let me simplify this because 3 and 3, they divide out, and I get that f of x is x to the third power minus cosine of x plus c. This is the most general antiderivative. But I was also told that the value of this antiderivative is 4 at 0, which means when I plug in 0 to this expression, I should get 4. Let's use the fact that f of 0 is 4, which tells me when I plug in 0, which is 0 to the third power minus cosine of 0 plus c, that should give me 4. Let's evaluate this. I believe 0 to the third power is 0, cosine of 0 is 1, which gives me negative 1 plus c is 4. Let's add 1 on both sides and you will get that c is 5, which tells you that your antiderivative doesn't have plus c at the end. Your antiderivative is f of x equals x to the third power minus cosine of x plus 5. This is called an initial value problem because you were given the value of the original function, the value of the function you were looking for at some point, in this case at 0. Let's see if we understand this process by doing another problem. We are given a function f of t, and we know that the second derivative of f is 12t squared. We know that the value of the derivative at 0 is 3, and that the value of the function at 1 is 2. If you would like to try this problem on your own, stop the video now. I know that the second derivative is 12t squared, which means I can find the first derivative. The first derivative is, I rewrite the 12 and I take antiderivative of t squared, which is t to the third power over 3, and I add c at the end. 12 and 3 cancel, and I get 4t to the third power plus c. That's my f prime of t. Do I know what c is? I know that the value of the derivative at 0 is 3. Let me plug in 0 to this expression, and I will set it equal to 3. Let's use this fact now, that f prime of 0 is 3. When I use this, I plug in 0 to this expression and I will get 4 times 0 to the third power plus c equals 3. Which tells you 4 times 0 to the third power is 0, which tells you that c is 3. Which means your derivative is 4t to the third power plus 3. Our goal was to find the original function f. Let me take the antiderivative one more time, and I get f of t equals 4 times antiderivative of t to the third power is t to the fourth power divided by 4. Antiderivative of 3 is 3 times t, and at the end I have plus constant. I already used the letter c before, let me use the letter d this time. I can simplify this because 4 and 4, they divide out, and I get that f of t is t to the fourth power plus 3t plus d. Can I solve what d is? I believe I was given one more piece of information. I was given that f of 1 is 2. Let's use this fact. When I plug in 1 to this expression, I will get 1 to the fourth power plus 3 times 1 plus d, and I'm supposed to get 2, which gives me, this is 1, this is 3, that is 4. So I get 4 plus d equals 2, which tells me that d equals -2. I subtracted 4 on both sides. The final result then is that f of t is t to the 4th power plus 3t minus 2. Let's try one more problem. This time we are told that the particle moves in a straight line with acceleration given by this formula, and we must find its position function s of t, given that s of 0 is 1 and s of pi is 6. If you would like to try this on your own, stop the video now. We know that acceleration is given by sine of t plus 2 cosine of t. My goal is to find the position function. I know that if I take antiderivative of acceleration, I will get velocity, because the derivative of velocity is acceleration. Let me first find velocity. The velocity, which I will denote by the letter v, will be antiderivative of sine is negative cosine of t. Antiderivative of 2 cosine of t is 2 sine of t. At the end, I get plus c. Can I solve for c? Unfortunately, I was given no information about velocity. This does not stop me. I continue taking antiderivatives because I know that the antiderivative of velocity is position function. If I take antiderivative one more time, I will get antiderivative of cosine was sine, so this will be negative sine of t. Antiderivative of sine is negative cosine, so I will get negative 2 cosine of t. Antiderivative of c is, that's a constant, so antiderivative of a constant is c times x. Finally, I add a constant at the end. I will denote it by the letter d. I found a position function, but my position function has 2 unknowns, c and d. Can I solve what they are? Let's use the initial values. Use the fact that s of 0 is 1 and s of pi is 6. When I plug in 0 to my expression, I get negative sine of 0 minus 2 cosine of 0 plus c times 0 plus d. When I do this operation, I'm supposed to get 1. Plugging in 0 should give me 1. Now, sine of 0 is 0. Cosine of 0 is 1, so I get 0 minus 2. C times 0 is 0, so I get plus 0 plus d equals 1. I add 2 on both sides, and I get d equals 3. I just found that my variable d is 3. This number is 3. Let's use the second condition to solve for c. I plug in 5 to this expression. Or I'm plugging in pi to this expression. Let me plug in pi to this expression, and I'm supposed to get 6. So in the first exercise, I guess in here, I only use the fact that s of 0 is 1. Now I am going to use the fact that s of pi is 6. I plug it in, and I get negative sine of pi minus 2 cosine of pi plus c times pi. Instead of d, I can already write 3. So I will say plus 3. That must equal 6. Sine of pi is 0. Cosine of pi is negative 1. So I get negative 2 times negative 1 plus c times pi plus 3 equals 6. Negative negative gives me positive. 2 plus 3, that's 5. Let's subtract 5 on both sides, and I will get 1 on the right side. And I get c times pi equals 1. Divide both sides by pi, and you get that c equals 1 over pi. Which tells you that your function is, let me copy it. That was the function here. But instead of c, I can write 1 over pi. And instead of d, I can write 3. This is my position function satisfying the two initial conditions.